Going live, session number 5, ANZ Coders. Here we go again. I hope you had time for a quick drink in that short break. This session we're doing Azure Event Hubs with Mr. Mitch Denny, who is currently on the other window and is going to say hello.
Hello.
There we go. That was awesome. So without any further ado, I'm going to hand over to Mitch, who's going to hit us with 30 minutes of awesome. Actually, before I do, I keep meaning to do this each session, but I've forgotten to, and that is the thank the sponsor part. So I have a whole 2 sponsors for this. One is Redify and one is Crowdcast. Crowdcast being the app that we're using at the moment for doing this, and Redify because they like me for some reason. So thank you guys, very appreciated. And Mitch, over to you.
Thanks, Richard. So as Richard said, tonight I'm going to be talking about Azure Event Hubs. I think I'm coming through okay, so that's all good. So I'll start sharing my screen. There we go. And hopefully it's coming through. All right, so tonight I'm going to be talking about Azure Event Hubs. Azure Event Hubs is an Azure service primarily targeted at IoT scenarios, but it doesn't have to be just for IoT scenarios. It's really about event ingestion at scale. If you want to contact me after the event and ask me any questions about what I've presented, feel free to shoot me an email. There's my contact details. So let's step back a little bit and talk about what Azure Event Hubs is. Azure Event Hubs is actually part of the data transport capabilities within the Azure IoT stack. So it's really about receiving data from devices deployed out in the field. So it's designed to solve 3 particular problems. The first one is ingestion of events at scale. The second problem is kind of a buffered receive mechanism. So the idea there is that one of your backend components can be offline and you've still got the ability to receive data. And the third capability is really about getting that sort of high scale availability that you might require. So the ability to deploy event reception. Event reception. Yeah, I'm looking down. It's the angle of a surface inside stock. It's designed to give you the availability of the ability to receive events at scale across various data centers around the world. So event hubs allow you to receive messages at 1 megabit per second per throughput unit. So you'll notice that on this slide here, I've got this little asterisk next to each individual bullet point. So you can actually scale up Azure Event Hubs to receiving about 1 million events per second is based on a single event hub within a single subscription. So whilst you can receive events at 1 megabyte per second, you can also read events out of the event hub at 2 megabytes per second. And the reason for that, of course, is to enable the backend system to be able to catch up with the number of events you're receiving. And then you've also got the ability to store events over a period of time. So event hubs don't just delete the events once you've received them. So I've been talking about events a lot. So what is an event? Well, an event is just a chunk of data. It's like a byte array with a wrapper of metadata around the outside of it. And so each event is measured in 64K increments. So if you send 1 kilobyte, you're going to get charged 1 event. But if you send 128 kilobytes, you're going to get charged 2 events. So you need to have a think about the shape of the messages that you're sending. Azure Event Hubs, it isn't for everything. It doesn't solve the problem of communicating back to the device. It's really designed from a large number of devices or components sending telemetry into a single point. It's not really designed to support broadcasting out to devices. So you might want to look at another communication channel for that particular kind of problem. And it's not a permanent data storage mechanism. So even though Azure Event Hubs can store events for up to 7 days, you're going to want to read that data out of the event hub relatively quickly. So what I thought I would do is just jump in and actually give you a quick demo of the portal experience around Azure Event Hubs. So let me bring up the window here. So I'm being brave and I'm using the Microsoft Edge browser here. So if it all hangs, then you'll know why. Okay, so what I've got here is a service bus namespace called ANZ Coders, and you'll see that Event Hubs is actually a tab within that particular service bus namespace. And if I drill in on that, you can see that I've got a service hub an event hub called Readings. And within the Readings event hub, you can see I've got, you'll see that I've been testing this thing a little bit over the last hour just to make sure it's all working. And if I look at it over the last 24 hours, you can see that I've pumped through quite a few messages just to test things out. There we go. Let's try that again. There we go. So you can see that I've pumped through a few messages today just to make sure it's all working. Within the event hubs, you've got the ability to configure policies that control how the event hub can be accessed. So here I'm retaining messages for only one day, but what I want to look at is the shared access policies down the bottom here. And you can see here that I've got a policy for sending messages, and I've also got a policy for receiving messages. And so this is an important thing with event hubs. You want to make sure that you set policies to strictly control who can do what. And when we get to looking at how the code works, we'll see how these particular keys are actually used. Now, the reason I came in here wasn't just to show you around the portal. I actually needed to cut and paste a value, some connection information out of the service bus namespace. So I'm just going to grab the connection string. Now, obviously, if you're using service bus, this is a very important connection string, and I'm going to use that a little bit later on just so that I can monitor events going through the system. I see a question there about the old portal, best portal thing. The truth is that Event Hubs hasn't surfaced beyond the coming soon inside the new portal. I'm sure it's on its way. Okay, so moving right along. So the way that Azure Event Hubs work is on the left-hand side, we have these publishers, and they send lots and lots of events. And those events go into an event hub, and the event hub internally is broken up into a number of partitions, and we'll explore what that means in a little bit more detail later on. And then on the other side of the event hub, we've actually got those same events coming out, and they're being read by consumers. And we'll see through this talk that there's actually a couple of different ways that you can consume events. So let's jump in and have a bit of a demo about how we can send events. And I've actually got two for this. So let me jump into Visual Studio. Can everyone see that screen okay? Do I need to up the fonts or anything like that? I'm happy to do it. I've got plenty of screen real estate. Bit of lag here. All good. Okay. All right. So So what I've got here is a Node.js program. So I'm going to show you how to send events into an event hub from Node.js and from .NET. So what I've got here is a Node.js application, which is using a little service bus library, which I've slapped together just to talk to event hubs. And then I've got a device type here, which abstracts away kind of like a virtual device for sending telemetry. And if I break into that, you can see that I send a reading to the server, which contains a timestamp in Unix epoch format, the device name, liquid depth, battery level, and water detected. And I've just got some temporary dummy values in there. So basically, this is just running on a timer. And in the Node.js code, what I'm going to do here is just spin up 100 devices, and they will periodically talk to the server. But one of the things that I wanted to talk to you about was how you actually secure these event hub services. So you can see here that I need to generate a shared access signature. And a shared access signature is generated by taking the namespace name in this position here, and the event hub name, and the device name, and running it through a hash algorithm to produce the signature. Now, what I've done is I've created a library for Node.js, which quickly generates those tokens, and I'll provide a link to that a little bit later on. Okay, so once I've spun up the devices, I then just start executing. Now, the active ingredient here is actually in this service bus library here. And so to push an event to Azure Event Hubs is as simple as creating a HTTP request. So you can see here that I've got the options for a HTTP request in Node.js to the service bus namespace, to a particular path, which is the event hub path, over SSL, and it's a post method. But the important thing here is I'm passing along an authorization header with the shared access signature. And provided you've got that in place, well, then you're in good shape. So let's jump back to the Node.js application and actually run it. But before I do that, I'm going to spin up a tool called Service Bus Explorer. So Service Bus Explorer is a pretty clunky tool. Now, if something goes wrong here with my audio, please forgive me. This tool, for some reason, uses quite a bit of CPU, but it's kind of the easiest way to show this stuff at work. So I'll just quickly jump back and grab that connection information again. Wouldn't you know it? There we go. Let's try that. Right, I'm going to have to quickly jump into Chrome to do this because for some reason the cut and paste out of Edge is not working. Gotta love that. Give me a few moments. I'll bring it over so you can see me logging in. I decided to change to using Microsoft Edge at the last minute, just so that it didn't interfere with the Crowdcast session, and I think it's going to bite me now. So I might just close down the Service Bus Explorer. No joy. I've got to actually better get it into the clipboard because I think this text box is not going to let me do it. I might have got it there. All right, let's jump into okay. Hopefully everyone can still hear me with the CPU maxing out over here. Hopefully that's all working. Quickly just type that in and you'll be able to access my Event Hub. So what's actually happening here is it's connecting to the Service Bus namespace and it's scanning through it for all of the assets. And what I've got over here is the readings Event Hub, and I've got a consumer group here called debug. So consumer groups we'll talk about a little bit later on, but just think of this as like a subscription to the Event Hub for the time being. And what I'm doing is I'm creating a listener, and I'm going to start that listener now. Because I've already got events in the Event Hub and they're stored for the whole day, the way I've got it configured, when I start here, I'm going to get a whole bunch of traffic. So I'm going to press start, and you can see that the listener graph here is actually showing me all the events. So at the moment, I've received about 8,000 or so events. It gives you some idea of the volume of data that I'm actually receiving. So I'm just going to stop that for now, or at least clear that. Actually, I'll let that run if it's keeping up okay. Okay, so that's catching up on all the events that I've been sending through the Event Hub for the day. And what I'm going to do is I'm going to jump back into Visual Studio and I'm going to spin up my little Node.js application and start sending events. Here's the Node.js application. And so I've got 100 devices that I'm simulating there, and you can see there the little JSON packets that I'm sending across to the Event Hub, and those would actually be streaming into the Service Bus Explorer right now. So I'll stop that now because I don't need to keep that running. You'll just, I'm sure you'll believe me that that's working. Exit the Service Bus Explorer and close my Node.js program. Okay, so that's sending events from Node.js. In .NET, the code's probably a little bit simpler because you can use some of the built-in libraries for Service Bus to do the work. So here I've got a program. I've got the same sort of structure where I've created a fake device and I new up 100 devices and start the devices running. And then in the device code here, I'm just using the Event Hub client, which comes as part of the the Windows Azure Service Bus NuGet package. So it's basically the same kind of code. You just get to use an out-of-the-box library that Microsoft's produced. But I could just as easily have done this with a simple HTTP request as well. You've just got to figure out how to produce the shared access key. Or sorry, shared access signature. Okay. So with that, I've posted all of these samples up on GitHub. So if you want to come back to the video later on and take down that URL, you can go and grab all the source code for this session. If you want to use Node.js and you want to use my shared access signature library, there's the package name there. I too use NPM. I'm a huge fan of Node.js. And Service Bus Explorer, whilst it uses a fair bit of CPU, it's probably one of the better tools out there for quickly diagnosing how your service bus operations are going. So let's now talk a bit more about how consumers work and how the actual Event Hub internal structures and partitions work. So when you send an event from a publisher into an Event Hub, the event itself is distributed across a partition. Think of partitions as a mechanism for adding concurrency to the Event Hub. So as you keep sending events, more and more events pile up into partitions, and based on kind of a hash algorithm, it will automatically distribute the events across the partitions. One of the benefits there is that if you keep the, I guess, the publisher identifier the same, you can help ensure that your events end up in the same partition. Excuse me. Okay, so let's actually have a look at receiving events. Inside Solution Explorer here, I've got two codes for receiving, two projects for receiving events. I've got the receive events with event receiver and receive events with event processor. So I'm going to look at receive events with event processor first, and then I'll come back to the event processor model. The program is really simple. What I've done is I've created an Event Hub client using the connection string for the Service Bus namespace. And you just need to add this particular piece of text to the Service Bus namespace connection string. That's the entity path. And the entity in this case is the Event Hub name. Once I've got the client, I can actually get the default consumer group. So remember that there's multiple consumer groups. There is a default consumer group, which is $default. Excuse me. And then once I've got the consumer group, I can create a receiver and wire it up to an individual partition. So I'm wiring it up to the first partition in this particular example. And then in this case, I'm just looping endlessly, pulling an event out and getting the bytes and turning it into a string and printing it to the screen. Excuse me. So if I go in and set this particular project to start, and Visual Studio gives me the ring of death. Okay, and hit start. Just doing a quick build here. Maybe I should ask you guys whether you want to see code camp back. This build's taking a long time to start up. All right, let me see if I can kill that build. Okay, I'll run it without debug for the time being. So maybe that's causing the problem. Wow, can't compile. All right, what I'm going to do is I'm just going to quickly exit Visual Studio. Obviously something's hung up. I found actually with Visual Studio 2015 that if I do some node debugging, sometimes Visual Studio itself becomes a little bit unstable. So I'm just killing Visual Studio over here on my other machine. go on. All right, so I'll start up Visual Studio again. Demo file. Wow. Okay. Bear with me. I've got one starting here. I think it's just running extremely slow for some reason. I think in this case, Richard, I'm falling off the edge and I've sliced my arm off at the same time. Okay. All right, look, I'll keep that loading in the background. I'll just keep moving along and I'll explain why the difference between having an event receiver and working with another model called the event process host is significant. Okay, so let's talk about receivers versus processes. So the way event receivers work is you have an individual event receiver and it's actually subscribed to an individual partition. And then with an event processor host, I guess it's a helper library that Microsoft's provided, the ability to create a single event processor host. And it manages instances of event processor, which then feeds off multiple partitions in the event hub. Now, the reason that's important is in the receiver model, if a receiver fails, well, then you stop processing events on that receiver entirely. Whereas model, you simply have a cluster of event processor hosts, and it automatically balances the load across the partitions, so that if one of the event processor hosts goes offline, the other event processors in the cluster can actually take over. Okay, so the other benefit the event processor hosts give you is that it gives you some automatic offset tracking. So one of the behaviors of Azure Event Hubs is that if when you receive a message, it's not actually removed from the underlying partition. And so the event processor host code has a mechanism built into it by default to keep track of where it was up to. So if you do have an event processor host go offline, the event processor hosts coordinate through a shared state bucket to figure out where they're up to so they can recover. And so by default, that's actually Azure Storage. And if I jump into the Azure Storage Explorer, you can see that I've got a storage account here, which is actually sitting underneath a event processor host. And we've actually got a blob there for every single partition in the system. And so if I open up one of these on the window over here, and look at the content in text, you can see that there's a JSON file here which is containing some metadata about where a particular event receiver is up to. So that's important to know when you're working with event processor hosts. Okay. So event processors. Hopefully Visual Studio is back up and running again. I've got 2 instances of it. And I open up my demo. And I'll just point out the difference with the code with the event processor host. See if there's any questions while waiting. Q&A, no. All pretty straightforward then. Wow, it's taking a long time. Don't know what's going on there. All right, well, moving right along, I'll let that keep opening in the background. So the other thing that happens with, as I've mentioned a couple of times, is that the events are stored over a period of time within the partitions. And so those events will actually age out in the order that they arrived. And that's important to remember as well. So whilst your backend consumers can go offline, they can't go offline forever. When are events cleared from the hub? So when you provision the event hub, you can specify the retention period, and that retention period can be up to 7 days. Now, the amount of time that they're retained is based on that retention period, but also the amount of storage you've got. So one of the earlier slides that I had was one of the earlier slides I had talked about throughput units, and I'll come back to throughput units in a little bit of time, but each throughput unit gives you an allocation of gigabytes for event storage. So if you use, I think it's 84 gigabytes per throughput unit. So if you have more than 84 gigabytes within your event hub, and you've only got one throughput unit, well, then those events are going to start aging out even before a day's up. It just depends on the rate at which those messages come through. So let's talk about those core concepts, because that might answer a couple of those questions. So within an event hub, so an event hub sits within the service bus namespace, and it's made up of partitions, publisher policies, which is the security, and consumer groups. When you create an event hub, the partitions are set and they can't be changed. By default, there's a limit of 32 partitions, but you can actually get that limit raised. Now, partitions aren't about scale, they're actually about concurrency. So provided your partitions can handle the number of messages going through, really what you're doing is you're optimizing for the number of I guess processes are going to be reading out of the event hub. It's actually the throughput units which have to help you dial up the scale. Kill edge, it's unstable. That's not a bad point. I haven't tried killing that. Let me see if it's still running. Although it didn't seem to be using the CPU. So let's go see what's happening with Visual Studio. No, Visual Studio is still dead. So I'll keep moving. Okay. So consumer groups, or consumer groups as I've typed it here. So consumer groups are independent groups of event consumers of the same type. So you might actually have one event hub, but you might have two consumer groups. And one of those consumer groups is a stream analytics job, or the other one might be a cluster of custom code reading off the same event hub. And each consumer group kind of has like independent pointers to the messages that sit within them. So think of it as a like a topics, like in service bus. As I said, security is set through publisher policies. So there's different permissions: send, listen, and manage. And so you create a shared access key with the appropriate permissions, and then you go through the various hashing algorithms. But one thing that you need to keep aware of is that you don't want to share that shared access key to your devices. What you probably want to do in most of your code is actually generate that shared access, the signature from the key, and then give the signature to the device. And that necessitates some sort of out-of-band key exchange mechanism. One of the things you might want to consider there is having a device registration backend, where each device calls in and says, "Hey, I'm here." And then once that device is whitelisted by some kind of administrative action on the back end, or even an automated action, then that device can actually get access to an actual signature that it can use for sending into the event hub. So that way you do a little bit of negotiation before you start streaming events into the event hub and driving up your load. From a scaling point of view, we scale through throughput units. And so what I've done here is I've just created a few little diagrams to help illustrate the concept. So I'm just looking at the questions here. Each new consumer will load the whole bunch of available events in the hub. Think of it as two different lenses over the same bucket of events, if that makes any sense. So it's not really duplicating the data, but it's it allows you to track state for two different groups, independent groups of consumers. Okay, so in a scale scenario, let's say that I'm receiving events at about 9 megabytes per second, and I'm reading out at about 0.2 megabytes per second. So at this point, I'm actually receiving events at a higher rate than what I'm reading them. And I'm getting a total number of calls of about 974 calls per second, and I'm running close to running out of storage. So in this model, what I'm probably going to need is more throughput units, because what I need to do is increase the volume of storage that I've got available, so I can increase the retention time, but also just the flat out storage, but also make sure that my endpoints or my devices that are sending events don't actually start getting errors. And eventually I'm going to want to increase my ability to process the messages. So I may also need more processing power. Final thoughts, and before I do that, I'll just jump back into Visual Studio and see if it's come back to life. And good. Okay, so here's the event receiver. I'm not going to attempt to compile this because what I wanted to do is show you the code. If I go into the receive events with event processor and go into the program, you can see here that what I do is I create an event processor host, and I give this particular host a name. I tell it what hub I'm using and what consumer group I'm connecting to, and then I've got a connection string to the actual service bus namespace and a connection string to the storage account. And then what I do is I register an event processor with the actual host, and that event processor implements a really straightforward interface here, which is close async, open async, and process events. The idea here is I get messages in batches and I can go through them and dump them out, and then I checkpoint them, and this actually calls back into the Azure storage account to keep track of the state. And so we looked at that a little bit earlier. I'm going to try and run this, and if it doesn't run, that's all right. We'll see if it kicks off. Be nice to drain the events anyway. Thanks, Richard. 3 minutes. Cool. All right. So that's not compiling for whatever reason. I think I'd have to reboot to do that, and I don't think I've got enough time to do a reboot. So all that code's available up on GitHub. So final thoughts. Best practices. Best practices are always a little bit dangerous when a technology is so new, but I would suggest that you're probably going to want to have a model where you have one event hub per kind of message that you're receiving, unless you can have some sort of standard message envelope that you're sending through and you differentiate later on in your processing pipeline. But event hubs, it's really the throughput units that you pay for, and throughput units are actually paid across the entire service bus namespace. So you can actually have plenty of event hubs. Look at that, my event hub processor is running. So there you go, it's receiving events, yay. The next thing you're going to want to do is, in the design of your system, assume that you're going to be creating and destroying event hubs all the time. So don't create a tight coupling between your code and a particular event hub. Establish a mechanism so that both your consumers and your publishers can change the event hub that they're talking to, and that means you need a mechanism for bleeding the final event sitting in an orphaned event hub. And then, as I've said before, build a device registration mechanism. There's my contact details. Open to Q&A, and if you want any resources, there are some links for you to copy down, but I'm sure it'll be there in the video afterwards. So with that, I will jump over to the window.
Fantastic, Mitch. Let's have a look at some questions. Do event hubs only operate with JSON? Could it work with other data types, XML, HL7, something else?
You can actually send whatever you like across an event hub, so you can send an array of bytes, really. But what it does do is impact what you can have reading it. So there's a technology called Stream Analytics, which can actually connect directly to event hubs. Now it takes whatever's in the event hub and basically dumps it into a table so you can do set operations. So obviously if it can't crack open the file, then it's going to have trouble processing that stream. But if you're in control of both the sending side and the receiving side, you can do whatever you like.
Cool. And I had one. I thought I'd throw in there. I was just thinking about the talk last night with microservices and event sourcing and everything else, would
Yep.
would this work as an event source storage mechanism? Basically, do you get to pull out events for an entity, for example? So if you had a GUID for an object, could you just extract the events for that from event hubs, or it doesn't work that way?
You're going to have a couple of problems there. So firstly, most of the event sourcing system, are you thinking about using it as an event sync so that if you need to reconstitute the system, you can? Is that the scenario? Yeah. So keep in mind that with event hubs, the event hubs themselves have a finite duration of events that they can store. So if you're looking to be able to reconstitute your event source domain model over a time frame that is longer than the event hubs can store, well, then you can run into trouble. So you'd actually have to combine that with some kind of checkpointing. It's probably in terms of the ability to scale to handle it, it's fine, right? But it's probably not cool for it.
Cool. Do we have anything else in the chat room? Good event hub discovery mechanisms that you know of, or is it a roll your own at the moment?
Good event hub discovery. So yeah, look, this is an interesting space. There is Clemens Vastas, I think, and some people at Microsoft have put out some reference architecture documentation, and that code includes the device registration capability, but it's such a common problem that I would expect it to be as part of the platform at some point in time, but not necessarily event hubs, because it's not just an event hubs problem, right? The event hub endpoint is just part of the device discovery metadata that you might need moving forward.
Mm-hmm. Okay. Anything else, guys? This is where we have to wait 20 seconds for everyone to respond. And if not, we definitely want to say thank you, Mitch, for a really cool session. Apart from Visual Studio and everything else deciding to hang and the demo god smiting you.
I'm blaming Windows 10.
I need a pipe to go with my dressing gown. Seriously. A monocle.
What's on the shirt underneath? What's the?
It's just a normal shirt. That's the Signal R shirt. Shooter.
Okay, there you go. Looks kind of like a Battlestar Galactica fighter or something. Anyway.
All right. Well, in that case, I'm going to call this session done. And more cup puzzles. What? I don't even know what that means. We're going to call this session done, and we'll jump in a few minutes into the next session, which will be Kanye giving us reactive UI. I'm hoping to get some good Yeezy quotes from Brendan when he does his thing. And again, thanks, Mitch. Round of applause.
My pleasure. Thanks, guys.
All right, later.